All right, so we're going to continue here with finding limits that involve rationalization or factorization. We already saw one example of factorization. Here we're going to take a look at how rationalization works. Okay, rationalization is a process where you multiply the numerator and the denominator by the conjugate of the denominator. Okay, so once again, if you kind of preview a step or two ahead, you'll notice that if you do a direct substitution in the denominator, what you'll find is that you're going to take the square root of 36, which is 6, and if you subtract 6, you end up with 0 in the denominator and in the numerator. So we have an indeterminate form. So we might think there might not be a limit or the limit doesn't exist. However, we should apply other strategies. And so we want to follow the hint here, which is to evaluate by rationalizing the denominator. Okay, so when we do that, the first thing we need to do is just find the conjugate. The conjugate of the denominator is simply going to be the square root of t plus 6. Okay, it's just changing the sign in between the two terms, and we're going to multiply by that to the top and the bottom, okay, of the existing rational expression. So we have the limit as t approaches 36 of t minus 36 all over the square root of t minus 6. Okay, what multiplying by the conjugate allows us to do is multiply by a factor of 1. All right, so what we'll do is we're going to multiply by the square root of t plus 6 all over the square root of t plus 6, right? So what have we really done? Well, if you think about it, what we've done is we've multiplied by 1, right? Square root of t over plus 6 all over square root of t plus 6 is just 1, right? However, it's going to allow us to rewrite this expression into something else that we can take the limit of. Okay, so in the numerator, what we'll start with is t minus 36 times the square root of t plus 6. Okay, there's a reason why I'm going to leave it in this product form, okay, and we'll see why later on. All over, now the denominator, this is where we have to do a little bit of work, all right? So we have the square root of t minus 6, and I'm bringing this off to the side so that we can see what's going on, times the square root of t plus 6. Okay, and I'm going to distribute. So I have the square root of t times the square root of t. This could be written as the square root of t squared, right? Square root of t squared, because square root of t times square root of t, it's like saying square root of t to the second power. Okay, then we have square root of t times 6. So that gives us plus 6 square root of t. Then minus 6 times, or negative 6 times square root of t, which is minus 6 root t. And then finally, negative 6 times negative 6, I'm sorry, times positive 6 will give us negative 36. Okay, so let's see what happens. 6 square root of t minus 6 square root of t, these terms actually cancel, right? That gives us 0. And then if you have the square root of t squared, well, square and square root, these are inverse operations of each other, right? They undo each other. So really what we have is just t minus 36, right? So the denominator ends up multiplying out to be t minus 36. And guess what? This is why I did not distribute the numerator, right? Because now look at what I have. I have this common term in the numerator and denominator, which is t minus 36, right? So what happens with these terms? They actually divide each other out. And what we're left with is the limit as t goes to 36 of the expression square root of t plus 6. So now the denominator, it does exist. Right now it's just all over 1, but we don't really even need to see that, okay, because the only term that we have left is in the numerator. So what we'll do next is we're going to go ahead and apply direct substitution, so we can take the limit as t approaches 36 of the square root of 36 plus 6. So this gives us the limit as t approaches 36 will be 6 plus 6, which is just 12. So we can say that the limit as t approaches 36 is 12.